Good morning, everybody. I'm going to teach a lesson today on continental drift and plate tectonics. We're going to talk about where these concepts come from and how do they impact our world today. But before I start, I want to tell you guys I really miss you all. I'd much rather be teaching in my classroom as opposed to my dining room here, but that's not possible. So I hope you're all being safe. I hope I see you all again soon. And this PowerPoint's going to be available on Canvas. And I hope you can find some use of hearing it from me as opposed to just clicking through the slides on your own. So, with that in mind, let's get started. Advance the slide. Okay, in the 16th century, there was a Dutch cartographer named Abraham Ortelius. He was the first one to suggest that the continents once fit together. And even though he was using a pretty crude map at that point, it's not difficult to see how that might have been possible, that the continents did indeed fit together. Kind of described it as a puzzle. So when looking at a map today, you can see it's even more apparent that maybe Africa and South America at some point fit together. But it wasn't until 400 years later that this idea was actually advanced further. It was this guy here. In 1912, a German meteorologist named Alfred Wegener continued exploring this idea that the continents might have moved around the Earth at some point and fit together, then broke apart again. He actually wrote a paper describing how the continents fit together, and his idea was that they all formed one giant continent, one big landmass. And of course, you know what he called it. He came up with the name Pangea, and that means all land. And so here's an idea of what that might have looked like roughly 250 million years ago, that all the continents had come together as one. So Wegener, in 1912, he stood before a delegation of scientists and he described his new theory. He was reading from his notes there. And at first, they listened closely, but at some point, they all started laughing. So his ideas weren't well received by the scientists in attendance, and you can probably imagine why. If you're going to give an idea, a scientific idea to a group of scientists, you better have your ducks in a row and all your facts ready, because otherwise they're not going to believe you. So after they stopped laughing at him, he began to present his supporting ideas that gave his vision validity, meaning truth, if you will. So he opened up the briefcase and he got down to listing his supporting ideas. The first evidence he brought up were fossil clues. Wegener spoke of a Mesosaurus, which is an extinct alligator-like animal that existed in bodies of fresh water many millions of years ago. And Wegener located the fossil. There's his fossil right there, the Mesosaurus. And the only two places on Earth you can find that fossil is here in South America and in Africa. And the suggestion is there that those two continents must have been together during the time of Mesosaurus. Otherwise, they couldn't have swam across a saltwater ocean, because again, they were a freshwater animal. And those are the only places you can find a Mesosaurus fossil. There's some other neat looking fossils. I would love to own one, as you guys can imagine, but it's going to cost you about $400, and I'm sorry, $4,000. So that's not in my budget right now. He also discussed a tree or fern-like plant called the Glossopteris, and then you can see some fossilized Glossopteris leaves. And you're probably wondering what's so special about a fossilized tree. You would probably expect to find a tree like that along the equator, kind of a tropical plant. But that's not where Wegener located these fossils. The fossils were actually located on this very, very cold island. Not Bouvet Island, as you might have guessed, but this is actually an island called Spitsbergen. It's a territory of Norway. Its climate is extremely cold. It's the last place you go to search for fossils of tropical plants. And you guys can see that's the North Pole right about there. And Spitsbergen is really close to the North Pole. So that's not somewhere where you'd think you'd find plants or fossils of plants. So it seems like that island must have moved at some point. Maybe from the equator, it made its move up to towards the North Pole over millions of years. But Mesosaurus and Glossopteris aren't the only examples of what we call fossil clues. There was also the Lystrosaurus. and his fossil remains can only be found in Antarctica and Africa. So the Lystrosaurus down here, you guys can probably see him there. If you look at his fossils, they kind of zigzag through Antarctica and a little bit through India there, then into Africa. And the only way that could probably happen is if those continents were once together. So there he is again. What a cool looking animal, huh? Completely extinct now. And then there's the Signophagus. And like the Mesosaurus, his fossilized remains are only found in South America and Africa. So again, his territory must have been connected at some point, and then those lands were split apart, which explains why we find them in separate areas. The second point of evidence that Wegener brought up was rock strata, or rock layers. He discovered that mountain ranges matched on different continents. For example, there's some rock layers of North America that matches rock in Africa. And as you can see on this map, that's not the only example. There's several areas on Earth where rocks seem to match up and then were broken apart. But the layers today, we can correlate those and see that they do in fact match up. So example there is Greenland possibly having split apart from Norway, and the eastern seaboard of the United States having broken apart from Africa. There's some examples in Africa and South America as well. But again, those were rock layers that matched up, so Wegener brought that up. In addition, his third point of evidence were these, what he called climate clues. And he discovered these massive boulders laying around in the savannas of Central Africa, and it just doesn't make any sense in a very warm environment to have these big rocks laying around that appear to have been moved around. And of course, the only thing that can move rocks that size would be ice. And how would it be possible that ice was in Central Africa at any point? And yes, it appears as though there were once glaciers in Africa, that maybe Africa was closer to the South Pole and had huge sheets of ice that were moving these big rocks around. And then once the ice melted, it left the rocks just laying around as they are today. And you can actually see drag marks in the ground behind these big rocks. Geologists have discovered these drag marks where you can see these big rocks were pushed across the African continent. So again, this is some evidence that Wegener brought up to try to convince the scientists that he was correct. Sadly, he died in 1930. He died, he was in Greenland, and his expedition got lost, and they froze to death. So Wegener went to his grave never knowing that his ideas today are widely accepted and appreciated by scientists everywhere. I own a book from 1939 about geology, and sadly, I looked in this book for anything about Wegener, and there was one little tiny mention of his idea of continental drift, and that's sad because up until fairly recently, none of his ideas were accepted. People thought he was kind of crazy. All right, so let's jump ahead 10 years later when World War II began. Oddly enough, World War II would lead to Wegener's theory being accepted. And you're probably wondering, well, how is that possible? So let's take a look at that. Though the war was mainly between Germany and England at this point, the U.S. was already sending weapons to England, who was our close ally or friend. And those weapons were going on ships across the Atlantic, despite the fact the United States wasn't yet involved. Lots of propaganda posters like this one, "Help Britain Defend America." You can see the boot of Nazi Germany coming down onto the Statue of Liberty. So everybody in America agreed that our friends in Britain needed supplies. Germany became aware of these U.S. shipments across the sea, so U-boats or submarines started sinking U.S. ships at an alarming rate. We were losing tons and tons of material being sunk by these German submarines. So we had to think of a way to counteract that. And so the U.S. found that destroyers, as they were called, could locate these U-boats. And of course, as the name implies, they would destroy them. U.S. Navy Captain Harry Hess commanded one of these destroyers that searched for U-boats. And these ships used a new technology called sonar to locate and destroy subs. A sonar is similar to what a bat uses when it tries to locate something like a flying moth in pitch black darkness. It uses echolocation and it emits a very high pitch, which then bounces off the moth and it's able to locate and capture the moth. This is kind of how they do it in a ship. These ships use the sonar, the sound bounces down to the bottom and can locate a whale, in this case, or an enemy submarine, and they can determine exactly where that submarine is. And so, once a sub was detected, they would roll off these big depth charges down to the bottom, and they would destroy these submarines beneath the waves. And that's kind of turned the tide there in the Atlantic, no pun intended. Now, when Wegener was looking for subs, he found that the seafloor was not flat as he'd expected it to be. And after World War II was over, he was done hunting submarines. He wanted to have a ship go out in the middle of the ocean and see what's going on out there on the bottom of the sea. Because again, at that point, we thought that the ocean floor was just flat. But that's not what he saw when he was hunting German submarines. So 20 years later, now we're in the 1960s, Hess was able to design and build the Glomar Challenger. It was designed to study the floor of the ocean, not hunt German U-boats. You guys can see it's a crazy looking ship because it has a big drilling derrick or apparatus at the very top there. That was his ship, the Glomar Challenger. And the ship detected an underwater mountain range in the Atlantic Ocean. And that underwater mountain range, as you can see, goes all the way down the Atlantic, basically zigzags down the middle of the Atlantic between North America and Europe and South America and Africa. And that's called the Mid-Atlantic Ridge. It's a massive underwater mountain range where two tectonic plates are separating and they're moving in opposite directions. As we've learned, the Earth is rotating very fast on its axis, and in addition to that, the Earth has an iron core. This combination creates a strong magnetic field that protects us from all the radiation coming from the sun. The reason I bring this up is because every 100,000 years or so, North Pole flips around to south, and the south becomes north. And it's not something you would feel, or there'd be no sensation of that. You would just find that your compass no longer works correctly because everything would be opposite. But the reason I bring this up is because Hess was able to determine that on either side of the Mid-Atlantic Ridge, the rock appears to change color on either side roughly every 100,000 years. So as these two plates are moving in opposite directions, as you guys can see the arrows indicating, new magma is pushing up and out of the seafloor, creating new seafloor. And when magnetic north is as it is today, you would get one color. And then when it flips around to the other way, the rock color would change. And that creates sort of a striping on the bottom of the ocean floor. And so Harry Hess realized that the seafloor was in fact moving apart at the Mid-Atlantic Ridge. So his theory, he called it seafloor spreading. The idea that new seafloor is being created all the time, not only at the Mid-Atlantic Ridge, but along several ridges around the globe. Poor Iceland. Iceland is literally sitting on top of the Mid-Atlantic Ridge. So the island is literally very slowly stretching apart. And you guys can see that Iceland is very, very volcanic as a result of being on top of the Mid-Atlantic Ridge. There's some cool pictures of it. These people are actually standing right on the edge of the Mid-Atlantic Ridge, and you can look down and see lava flows going on down there. Iceland also has free, abundant